Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I am Paul Mackin, one of your hosts this evening, and I am joined by Professor Allan Hyde. We are broadcasting live from the Allan Carswell Observatory, located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time at York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV feed run by the observatory staff. To navigate to our line show or to find out more about us, please check out our website at yorku/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram with the handle at York U Observatory or on Facebook at Allan I Carswell Ob. All of our programs are free, but if you'd like to make a donation, and we would certainly appreciate that, please see our website at yorku/science/observatory. We will be monitoring the YouTube chat for questions and post content. Tonight's weather isn't great for observing, but we do have our staff in the domes, and we're going to be operating our OPV with archival images. The weather's not great where I am, Elena. How is it in your neck of the woods?
Yeah, it is Toronto weather for sure. We have thick clouds, high humidity. I can't see any chance of opening the domes tonight. So I imagine that our crew will be in fact going ahead with the archival images. And it's a perfect night for some data reduction. So maybe we can all get caught up on that a little bit.
Yeah, it's I'm a little north of the observatory in a place called Newmarket, and I was hoping to get one of my scopes out tonight, but no such joy, I think. But that being said, we've got our show to do, and there'll be lots of interesting discussion points there. So why don't we get going this evening with a little bit of space history? So,
Absolutely, that's a great idea.
yeah,
I see you're skewed up first.
I am absolutely, yes. So this is not really an astronomy or space story directly, but on May the 4th, 1977, the film Star Wars was released in theaters worldwide. It was actually pretty revolutionary and changed how the public appreciated science fiction films. Until then, good science fiction films were relatively rare. 2001: A Space Odyssey was probably perhaps the best of them. Another candidate would be The Day the Earth Stood Still. And some, would stay, both those films still have their advocates and defenders, so they might claim they still are. But Star Wars, which was later renamed Star Wars: A New Hope, was different. It featured amazing special effects for the day. It had a very simple, easy to understand plot. It had heroic characters, epic villains, and kind of charming sidekicks. So 48 years later, fans still celebrate May the 4th with the catchphrase, "May the 4th be with you," which is a juggle of the words in the benediction, "May the Force be with you," from the film. The story steals freely from other writers' science fiction novels. Dune is in there, Foundation is in there. George Lucas, stole from the best. But it does those pilfers, I guess, from those novels in a celebratory way. The movie, though, did enormously well at the box office, and it has been released multiple times since. Um, and it paved the way for not only 8 sequels, but multiple TV shows, hundreds of books, cartoons, games, memorabilia, swag. You can get Star Wars bed sheets. My kids had them when they were young, and so on. Um, it also caused a renaissance in science fiction films. So 2.5 years later, inspired by the success of Star Wars, the Star Trek franchise moved from TV, where it had gone off the air kind of unceremoniously about a dozen years before, to the big screen with Star Trek the motion picture, which also, had a lot of the same things. It had great special effects. Maybe the story was a little more complicated and so on. And that has now led to 13 Star Trek films, an additional 9 TV or streaming series still going on, and again, hundreds of novels. So both franchises are still going strong. Star Wars for nearly 50 years and Star Trek for nearly 60. Now, why this is significant is that it led to a change in attitude towards science and space exploration. I remember attending the opening day of Star Wars in 1977. I'm a little older than a few of my classmates, and I was, I think, 17 or 18 at the time. And I also remember the first human broadcast from the moon in the summer of 1969. These are kind of social commentaries that have influenced my generation and those that followed, with these fictional representations of space and space science. And it really has, changed a lot of the world and how the public perceives space travel. NASA is to this day one of the most popular agencies in the US government, and European space agencies similarly revered in Europe, and the Chinese Space Agency in China. So, Elena, I've been to your office at York, and I know about your memorabilia collection. Do you remember the first time you saw Star Wars?
Well, you know about part of my memorabilia collection. Um, it's
Yes, I haven't been to your home. So,
that's, but yeah, I actually don't remember myself where I first saw it. I didn't have great access to movie theaters. I think I might have rented it from a library at some point. But I did actually have my first ever organized uh, organized social resistance protest in favor of Star Trek in my living room with my two little brothers and my sister, and signs and banners, so that we would be allowed to watch the original series when we got back from school. It was my first real effort at convincing the literal patriarchy that, or my parents, that it was in fact a reasonable request to watch Star Trek after school. It was on reruns at that point. So I think both of these major franchises have one great advantage for astronomy in that they spark the imagination. And in both the cases of Star Wars and Star Trek, and I know a few more from Star Trek, is a lot of the things that were dreamed up on the shows became aspirational. So things like tablets and communicators, or as we call them now, cell phones. um, these things actually, people became very passionate about trying to build them, and in a lot of cases they succeeded. And in astronomy, we have the lucky, I suppose, position of being able to study things like exoplanets, planets around other stars, and try to imagine the kinds of life forms that might live in those environments, if there are any. And of course, you need a bit of imagination for that. So I think that, if you're going to go and capture people's imagination and get them interested, especially in space science, both of these are a wonderful window in however you end up entering.
yeah, it's funny you mentioned, you're dealing with your parents and getting them on board. I remember it would have been in the late 70s, I suppose. I was in high school, and it was a New Year's Eve, and my grandfather was over at my parents' house, and he was an old ex-World War II veteran, Sergeant Major type. He was actually quite a loving and warm man, but he was conservative and he was really old. And there was a Star Trek episode on, and it was one of the comedic ones called "A Piece of the Action," and he was howling. This old Scottish man was howling with laughter. I was scared he was going to have a heart attack. He was laughing so hard. So
Mhm.
it was multi-generational. It could really reach across generations. But are you prepared, Elena, to weigh in on the Star Wars, Star Trek debate? There's been one going on which is better for decades now. Do you have a place on this?
Well, I think it's everybody gets their own personal favorite, and I would say the one thing I would hope most of us would avoid is if someone does have a favorite, let them have that favorite. It's fine.
Absolutely, absolutely.
Personally, I have a personal favorite, and it's one that I sort of developed over time as, the original series has a special place in my heart. I literally fought for it. Not very hard, mind you. Very forgiving mom on this case. So, but it's still one of the ones I enjoy going back and watching for lots of reasons, including the fact that it has a lot to say. And I know people who go back and watch Star Wars for the same reason, or maybe people who go and there's some wonderful stories from some older science fiction writers who wrote even much before the Star Trek Star Wars debate came on. Folks like, Robert Heinlein and, of course, Isaac Asimov and, Arthur C. Clarke and, even astronomers writing science fiction. So I don't know if you know this, but Fred and Geoffrey Hoyle. So Fred Hoyle is quite a famous astronomer. He actually wrote science fiction books with his son, and
He
they're actually
did.
they're quite good. So if you have a
Yeah,
few of those, um,
October the 1st is too late is the archetype of that. It's a classic book. He wrote that one on his own, but then after that, he started writing with his son. And he was the astronomer royal. You don't get
yeah.
any more serious than that.
Yeah, and so it's wonderful because I think, it just shows that especially in astronomy and in physics, there's a lot of folks who really are doing it just because they are quite passionate about it, and we do love talking about this stuff as is evidenced from our ongoing radio show.
Absolutely. But no, and I think ultimately, no matter where you come in this debate, both those shows are fiction, and we astronomers all know that truth is both stranger and frankly more interesting. So maybe we'll get into some science fact here. Elena, what else is going on in space history?
Well, I actually have a May the 4th. So, keeping with our theme, I've gone into science, astronomy history, and I'm going to go to May the 4th, 1989, and a little bit of a May the 4th be with you. This was a really interesting mission by the U.S., who did a Magellan orbiter, and this was a high resolution radar mapping, and it came about because in the late 1970s, so we're talking about Star Wars in 77, there actually was a lot of interest in mapping the mysterious planet of Venus. Thick, thick cloud cover. Science fiction authors had been speculating about it for quite a while. But the 1970s were, a very big time for lobbying for more science, especially in the US. And in 1989, we got the Magellan spacecraft, and it's a rather interesting mission out to the surface of Venus. Now, unlike the Soviet program, they did not try to get through the clouds with their physical structure. The Magellan spacecraft was a pretty massive, by I suppose today's little tiny satellite standard. It was over 1,000 kilograms, and it was launched by NASA on May the 4th, 1989. And it was out there to map the surface of Venus using what they called synthetic aperture radar. And basically, this was designed to peer down through the clouds. And synthetic aperture radar is a pretty fun thing, actually. It's not just a fancy term. This radar can actually create 2 or 3-dimensional reconstructions of objects, such as landscapes. And I believe this is also where some of the first material for what they produce in those. If you've ever been to one of the little 3D theaters where they show astronomy videos of flying over Venus, this is how you would make that map. So this was one of the first interplanetary missions to be launched directly from the space shuttle. Um, and of course, we no longer have the space shuttle, sadly. But it was a partially reusable low Earth orbital spacecraft system, very, very handy for things like Hubble, which I believe we'll might be talking about later. And of course, good for bringing up sort of large, bulky things like a 1,000-kilogram Magellan spacecraft. So the radar mission was a great success, and the spacecraft design was pretty interesting. Of course, Magellan being Magellan, it's designed to fly by, and it had orbital paths for collecting data. And so what they would do is, of course, this atmosphere of Venus, which we can admire actually from Earth naked eye, because of course, when Venus is close to Earth, it gets very, very, very bright, sometimes called the morning or the evening star. You can watch Venus go through its phases, just like the moon has phases, so does Venus. If you've got binoculars, it's so bright, you almost don't even need, well, you don't need assistance to see it, but even the small binoculars will be enough to pick out its phases. But you can't get detail of the surface other than it looks bright and white. And if you get a little bit of more resolution, it can look a little bit sort of bluish sometimes. But it's incredibly thick, incredibly hazardous, incredibly poisonous atmosphere. And we've talked about the atmosphere of Venus before on this program. It's worth mentioning that it is a 96.5% carbon dioxide, and its average surface pressure is 92 bars, which doesn't make a lot of sense to most folks, but basically, if a human, an average-sized human, went to Venus, you would be crushed to roughly the size of a tuna fish can, like a small tuna fish can. It's incredibly high pressure. It's got sulfur dioxide. It's incredibly hot. It is a very, very, very hostile environment. And of course, the fact that the Soviets were able to land a few missions onto the surface of Venus and return pictures with the Venera program is pretty impressive, actually. Magellan went right over that problem, both literally and, well, literally is the more important one. And of course, they had a high gain parabolic antenna, and that would bounce down. And so, if you've ever seen those like sort of radar maps where they show sort of sound waves echoing off, or undersea mapping that they do from boats, it's kind of the same idea. The radar system that was on Magellan, of course, was top of the line for the time, and it had basically use of this 3.7 meter parabolic high gain antenna, which would go through and sweep over to scan through the clouds and get a good view of the surface of Venus. Though they basically had fairly good lifespan for this craft. It was up there for quite a while. So we had 1989, it was launched. It was deployed from the space shuttle Atlantis a day later, so on the 5th, so over to today, in 1989. And it began its primary mission in 1990 when it reached Venus, and it began its orbital sort of insertion maneuver where it changed its path to go into orbit around Venus, and it started mapping. And using this radar to map the surface, you can only scan down sort of one little area at a time. And it did this through 1990, 1991, 1992, 1993, 1994, and it had 6 different mapping cycles. It did have to take a little break in 1993 to do a little aerobraking maneuver to get into a circular orbit. And in 1994, they actually began what they call the windmill experiment. And finally, they had an end of mission in October of 1994, where they deorbited into the Venusian atmosphere, crashing through the Venusian atmosphere. So not even trying to land. They're just so there might be a little bit of it left on the surface, but I sort of doubt it. It wasn't meant to survive that kind of intense Venusian atmosphere. But it was a very successful mission that created a lot of really wonderful data. And of course, being able to map the surface in great detail has made it really clear to us just how dangerous it is to have an incredibly thick greenhouse effect on a planet, because you have this incredibly acidic, high temperature, uh, hostile environment over on Venus. And there might be some chance of doing things in the clouds of Venus, which has been proposed before. Um, they haven't yet done anything with it, but I kind of like the idea of maybe them sending one of these possible blimp missions to fly around in the clouds above. And but living on the surface of Venus would be absolutely impossible for humans or for any aliens that you might think of from either Star Trek or Star Wars. So a little bit of trivia for our fans, I suppose. If you can think of a fictional alien that would meet the physical requirements of being able to survive on the surface of Venus, and I actually just thought of one, so I'm not gonna I'm not gonna spoil it.
You know,
So that's
yeah, I was going to say it's kind of funny. You mentioned the Venera spacecraft. I don't know if you'd heard that one of those failed to escape Earth orbit. It was in a very high orbit, and it's been there since the 70s or 80s when it was launched, and it is now about to come back to Earth,
yeah,
like
that's
in the
my news
next.
item.
Yeah. Oh, sorry, I missed that. I
We'll
missed
definitely
that.
cover that. We'll definitely cover
Yeah.
that in the news section.
Okay.
It is really interesting, and it actually was part of a spotter program that you could try to spot it on flybys as it went around Earth.
Yeah.
That
So
will no
that's
longer be possible shortly, but yeah, that we'll talk about that in the news section for sure.
yeah, that's amazing. But
Absolutely.
also in terms of planetary exploration, on May the 5th, so today, 2018, NASA JPL launched the Mars InSight lander toward the Red Planet. This spacecraft successfully landed at Elysium Planitia. I'm always bad with these Latin names in November of that year. While it was designed to last one Martian year, which is about it's about 2 years and 40 days for an Earth year. Um, the spacecraft operated twice as long as that. InSight's primary objective was to study the earliest evolutionary processes that shape Mars by studying the size, thickness, and density of the overall structure of Mars' core, mantle, and crust. Um, and the core's a lot smaller. Mars is a lot smaller than Earth. Thus, the core's a lot smaller, but the mantle and the crust are much bigger on Mars. It's a colder planet. It's geologically a colder planet, and it was also designed to monitor the heat rate of heat exchange from the planet's interior. InSight also provided us a glimpse of the evolutionary process through that heat transfer analysis of all of the terrestrial or rocky planets in the inner solar system. Um, InSight was part of a new wave of exploration robots for Mars. There had been a hiatus in spacecraft to the Red Planet after the Viking missions in the 1970s. In 1997, the Pathfinder Sojourner mission resumed exploration, and that exploration wave continues to this day. But it's not just the U.S.; it's the Europeans are there in a pretty big way. China's put a lander on Mars now. I think uh, some countries in the Middle East have done it. The United Arab Emirates, the Indians have done it. Mars is getting a lot of attention, and so it should. It's the most Earth-like planet in the solar system. And of course, there's also a lot of focus on manned missions there and whatnot. But InSight was the first spacecraft that was focused downward as opposed to looking at the surface conditions on Mars. The instruments on InSight included a seismometer and a heat transfer experiment, which was called the MOLE, and it didn't work really well. It wasn't able to penetrate the surface very far. It was designed to go down, I think, a couple of meters, and it went down a couple of centimeters. But there was some data acquired, and the seismometer experiment was extremely successful. And there were other experiments on it as well. But the seismometer captured over 500 Mars quakes. And it really gave us increased our knowledge of how terrestrial planets are structured and formed. The mission was not without mishaps. Uh, Including launch delays. They actually were supposed to launch 2 years earlier, and they discovered a leak in one of the pressure vessels in the spacecraft. And then we had the mole issue on the planet. But overall, it was a resounding success. And in August 2024, more than 18 months after it was shut down, and this is a theme we've explored many times here on York Universe. There was some data mining for the stored data, and data from the mission was used to demonstrate that there was a reservoir of liquid water on Mars, deep in the rocky outer crust of the planet. The findings came from a new analysis of the seismometer data, which recorded 4 years of vibrations and Mars quakes. The study revealed that the reservoirs of water were at a depth of 6 to 12 miles or 10 to 20 kilometers in the Martian crust. And it brought to the surface there'd be enough water there to cover the planet to a depth of nearly 2 kilometers. Like I think it's 1.5 or 1.7 kilometers. So it's an enormous amount of water. And then of course on Mars as well, you've got water in the polar caps, and there seems to be some subsurface water as well, like not this far down, but just below the surface. So Mars, it's cold, which is why it's not liquid wet, but it's got lots of water.
Yeah, it's amazing. It's and of course, that was one of the big debates for Mars for ages and ages is is it a dead, dry planet? And of course, the proponents of water kept bringing more and more evidence for water on Mars. But the InSight lander was a huge boost. And if you want a great sci-fi crossover, since this is a sci-fi episode, I will just mention that the wind sounds on Mars captured by the InSight sensors, you can go and play those right now on the science.nasa.gov mission site, and they are absolutely spooky. So it's one of those cases where it is better than anything you could imagine from science fiction as a spooky planet sound, a spooky extrasolar planet sound, because it's a real spooky extrasolar planet sound, or a real spooky extra Earth planet sound. And of
It's
course,
fascinating. Yeah, it's fascinating because those microphones were placed on InSight after a lobbying effort by the Planetary Society, which
mhm.
is non-governmental. It's space enthusiasts, and you're right. It caused a huge upswell in public interest. It's fantastic.
Yeah, and of course, Mars is by its nature, as you say, very, very interesting. It would not crush you to the size of a tuna can like Venus. Though theoretically you could, if you were a human in a protective spacesuit, walk around on its surface. And it does have an interesting amount of resources compared to, the small amounts of water that we found on the moon. So much more water on Mars. And it doesn't have a particularly hospitable atmosphere, but it's nowhere near as bad as the moon or Venus or Mercury for that matter.
Yeah, absolutely. But I notice we're at halftime, so I should probably do our reminders, and then we'll go back for your last space history story, Elena. So you're listening to York Universe. We're broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join our chat if you have questions or would like to see some of our content. Tonight, you're listening to Professor Elena Hyden and myself, Paul Mackin, and we're discussing some historical items. If you're interested in our online public viewing, please navigate to our website and follow the links where you'll be joining. That's a lot of fun. And tonight, because the weather's not cooperative, we are showing archival images, and there's some amazing images we're showing. We do have a couple of other reminders for this week. As in most cases, as in most weeks, we'll be hosting live observing, which is weather dependent, at the Arboretum. And we're also doing that with the RASC, the Royal Astronomical Society of Canada's Recreational Astronomy Night this Wednesday. This is a great opportunity to come out and look through a number of telescopes. And it's on the 5th floor of the Arboretum parking garage at our Keele campus. Tickets are free, and there's a link on our website to get to them. And of course, we're a student-run organization, and we're always open to getting donations. We would appreciate that. On alternative weeks, we mix those up with observatory tours in our main domes, where you can get up close to our 60 centimeter or 1 meter telescopes and hear about the work we do in the astronomy department at York University. Those tickets are also available the same way as for the Arboretum tours, and we alternate between observing tours and star nights at the Arboretum weekly, again, weather permitting, over the spring and summer months. But the observatory tours go ahead. You might not be able to look at the computer through the telescope live, but we do those tours if the weather's inclement in some way.
Yeah,
So, Elena,
absolutely.
so do you want to take us to our last news
Well,
item,
I'll just
Elena? Oh,
add one
sorry.
more little
Sure.
announcement to what you said is that, in terms of sparkler announcements, I would just say for the observatory, please folks make sure to look out for the upcoming astronomer in residence. We actually have our first astronomer in residence is going out to Killarney Provincial Park May 26th through June 1st. So keep an eye out for that. And we are going to be launching tickets. They're not going to be free, but it is going to be amazing to the open air Astro Fair at York University with the Allan I. Carswell Observatory. And the event will not be until June 24th through July 4th. But the tickets will be going on sale in the next 2 weeks. So very exciting times, and of course, very exciting Mars exploration that we're doing here. Um,
Yeah, and that the astronomer in residence program, very exciting, and we always get nice feed on the blog and whatnot, nice feedback on the blog and whatnot. So that's great.
yeah, even if you're not planning on going camping at the beautiful Bordeaux Dark Sky Preserve of Killarney Park, you can still follow along with the blogs and plan your camping for next year. So yes, of course, I have one last little item that I'll probably do a little bit quickly. Now this Mars we're talking about, I really like that you brought up the InSight lander, and of course it's spooky, spooky sounds, but also its amazing mission, because Mars is one of those planets where you really can tell that the science fiction writers took a lot of inspiration from Mars for some of their science fiction worlds. And these are, of course, in galaxies far, far away. Things like, I believe the Star Wars, it was a Tatooine, the sand planet. And of course, in Star Trek, we had Vulcan, which I know a little bit more about. So I could be like, oh, well, red planet, thin atmosphere, harsh conditions. That sounds very familiar. Mars is, of course, really all of that and a little bit more. So for my last item, I wanted to do a really fun little adventure that's near and dear to my heart. I still have the laptop sticker from the mission. But May 12th in 2010 was the end of a really amazing Mars exploration. The Phoenix spacecraft finally was unreachable, and was declared it was finally over in Mars 12th of 2010, which is just about this week almost. And the Phoenix is a really, really interesting Mars mission. It was an uncrewed space probe that landed on the surface of Mars in May 25th of 2008. And it didn't have the incredible long life that you see on some missions. It operated until about November 2nd of 2008. And they tried to keep contact with it all the way until May 12th of 2010. Um, its instruments were specifically designed to look at, and this is again what we were just talking about, the history of water on Mars, because we do feel like there's very strong evidence that there used to be a lot of water on the surface, and now there's a lot of water pretty far underground, or a little bit underground at least, in various parts of Mars, which has been well mapped. The mission was part of what was called the Mars Scout program, and it was a joint agency program which was led by a couple different folks. They had the NASA's Jet Propulsion, or JPL, Jet Propulsion Laboratory, but it also actually involved the University of Arizona and their Lunar and Planetary Laboratory. And that's where I actually get to come into the story very, very briefly, because I was at the University of Arizona when they were preparing for this mission, and I managed to get one of their stickers. So it was very, very exciting. Of course, the Phoenix mission came about because of a bit of a failure. So the Mars Climate Orbiter and the Mars Polar Lander were both lost, and NASA's better, faster, cheaper ideas of the 1990s were a bit reevaluated. Like, okay, maybe we don't go quite that cheap and fast. Maybe we do it a little better. And so losing Mars Polar Lander meant that some of those components could be reused, and some of them were. There's some debate on whether or not this actually saved any costs, but the Phoenix mission basically brought back some of the aspects from these other missions that hadn't quite made it. And so Phoenix landing on Mars and literally digging up ice was just an amazing success. So they tried to keep contact with it, and they finally finished the official mission in 2008, but by 2010, May 12th, that was when they said, okay, we're not going to be able to continue to talk to this craft. It's not responding at all anymore. So it did finish all of its planned science experiments and observations looking at the geological history of water on Mars, and of course, climate change on Mars. So much like Venus, Mars also had some pretty massive climate change, taking it from a place that was reasonable to a place that was pretty extreme. So Venus went to the thick atmosphere extreme, and Mars went to the thin atmosphere extreme. And looking at how that happened, especially on Mars being a lower mass planet than Earth, it sort of tells us a little bit about possible habitability for those folks who want to maybe go and live on Mars someday. You're going to have to know where the water is. So one of the main missions of Phoenix was follow the water. It did actually go quite a bit longer than the original 90 days that it was expected to live. And it was interesting because they sent it to a location where there was a good amount of ice. And there's some wonderful pictures you can look up where there's a little robotic arm on Phoenix which dug into the Martian soil showing ice, which then sublimated into the atmosphere. And sublimation is when you go from a solid state directly to a gas. So there's no liquid phase in between for water on Mars because the atmosphere is so extreme that if you have ice on the surface, it sort of immediately becomes a gas. A little bit like what happens to dry ice in Earth's atmosphere. Um, so if you've ever seen that. And of course, one of the principal investigators for the Phoenix, I just have to give a little special shout out to Dr. Peter Smith. And I got to take a class from him on planetary exploration where I advocated humans exploring Mars, and he told us all we were wrong. Robots should go. And fair enough, he did help send an amazing robot, so the Phoenix Mars lander. It had a wonderful mission, and of course, looked at things like the different gases and compounds in the soil. So it had a what they called TIGA, which was a gas analyzer, which took little pieces of Martian dust and actually baked them and looked at vapors. And so they could tell what was in there, and they could find out how much water vapor and how much carbon dioxide were in the samples that they were able to pick up. They actually did measure, and this was one of the controversial things, organic volatiles, in addition to things like methane. A wonderful mission, and of course, sort of ending on this almost this week in history, I had to put it in here because Mars is definitely still one of my personal favorites, even if it doesn't have any actual Martians on it that we know of.
Yeah, I remember that mission, and I remember, it was a recovery from another failed mission. They used the same hardware platform, but remarkable. And you again, we've talked on this podcast before that these spacecraft are over-engineered. They almost always exceed their mission lifetime. And Phoenix, it rose from the dead of a previous mission, and it nearly doubled its life expectancy under the harshest of conditions. So that's a tribute to human robotic exploration of space, and to some of the work NASA's done. But in the news, there is a fair bit of confusion in the U.S. space program these days. Just as the second rocket stage is being added to the Space Launch System rocket for the upcoming Artemis 2 mission to the moon. And that's a mission that will feature Canadian astronaut Jeremy Hansen as a mission specialist. And he'll be the first Canadian to leave low Earth orbit. So today, the White House released its proposed NASA budget, for 2026, and that cancels the Space Launch System and an associated mission, which is the Lunar Gateway, which is a deep cislunar space station, kind of orbiting, you could say, between Earth and the Moon, but it isn't. It's in a weird kind of orbit around the Moon, and it would be used as kind of a central location for lunar landings. And this does bring into question how NASA will return to the moon. But there is a plan in this budget document. So the new plan would have the Artemis 2 mission, fly in 2026. So yay, go Canada. And, astronaut Hansen, Godspeed. And then the Artemis 3 mission would fly in for a human lunar landing near the south pole of the moon, probably in 2027. And they're both going to use the SLS launcher and the Orion spacecraft. However, after those missions, there'll be no further Artemis launches. So, the Orion spacecraft, dead end, the SLS launcher is now dead-ended. But instead, there'd be continued investment in commercial launchers and landers, which could include further lunar missions. The plan here seems to be to beat China to the moon, and then step back a bit. China has plans for human landing on Mars around 2030, and the US would like to beat that. But this will be challenging, and these budget cuts are significant. And part of the challenge is that the SLS has failed to meet a single deadline and Orion, that it's had set for it. And Orion has also had a lot of technological and scheduling problems. So we're already quite far behind where we'd hope to be in terms of going back to the moon. But hopefully we can still do this. But the, this is a big change to the U.S. space budget. But the good news is that U.S. is not the only game in town. China is investing heavily in its space program. Mentioned earlier, they've been the second nation to put a successful lander on the surface of Mars. Um, you know, and the EU is also doing a lot of great work through the European space agencies. Japan doing a lot of really interesting work in space science as well. And Japan's got a bit of a focus on asteroids, which is a lot of they've had some great successes, and they've got a big mission coming up going back to Mars to do a sample return from one of Mars's moons, Phobos. So bit of a change in strategy. I'm still hopeful personally that we'll get back to the moon this decade. I we'll see how that shakes out, but this is a big deal. And the cuts on the space sciences and earth sciences funding at NASA are really gonna cut to the bone a bit. So there's a bit of good news that we're still keeping on the track that we're on, but longer term, there's some tight belt tightening ahead at NASA.
Yeah, exactly. And I think you're absolutely right. A lot of folks are looking in other directions as, maybe we can team up. And I would say definitely, in addition to, of course, China and ESA, there's some really interesting stuff happening over at the Indian Space Research Organization, or ISRO, and their missions have been really, really successful. They've had 3 missions to the moon and a mission to Mars, and they actually have a human space flight program up and running. And given their amazing, well, not necessarily amazing, but just fantastically wonderful successes that they've had with their relatively lower cost programs, I would say that um, you know, uh, keep an eye on that space, because the ISRO might beat everyone there. Um, I'm not quite sure how far they've gotten along recently, but it's been really interesting watching them with their lunar and their Mars missions. Just amazing success.
Yeah, their human rated spacecraft is being tested. It's They haven't launched humans yet. The Chinese are doing really well in that.
Yeah.
The Russian space program, which was such a trailblazer, really they focus now on, not to dismiss it because it's technologically very challenging, but kind of a taxi service to the ISS, which is coming to the end of its life in not that many years. So there's a lot of stuff changing, and that's kind of a technology maturation cycle as well. Moving more commercial, moving to other countries that weren't quite leaders, but it is. It's definitely changing times. And but on that, going back to the Russian space program, I unfortunately spoiled your news a bit, but please go ahead and tell us about Cosmos 482.
Yeah, so I mean, going back to Russia, one of the very big players in early space exploration has a little bit of an interesting situation going on. There's been a lot about talking about monitoring satellites and what you do when orbit starts to degrade, and of course we're all familiar with things like the Starlink problem with lots of satellites. But this one is, yes, it is different. So Cosmos 482 is in the news all over right now because Yeah, it's a little bit of Venus. Basically Russian spacecraft, as you say, from the Venera era, and it was Cosmos 482. It was launched from the former Soviet Union in 1972. So back in that really interesting era that we were talking about. And when they launched it, they were hoping that, of course, it would go out and do lots of great exploration and go to Venus. But it had a little bit of a problem. It was a booster failure, I think it was. Yeah, booster failure. And an upper stage rocket booster didn't quite do what it was supposed to. And it got up and just sort of stalled in this elliptical orbit around the Earth. And it has been there since 1972. So it's been there for quite a while, and they couldn't do anything with it. They couldn't control it. They couldn't really adjust it. So it's just sort of sat up there, changing its orbit slowly, slowly over time. Every time it goes around Earth, it would have a slightly more decayed orbit. Earth's gravity doing a little bit of work to kind of bring it closer every time it goes around. And so it's currently forecasted for May the 10th as a reentry for this probe. And of course, people are watching it with telescopes, much like our own telescope at the Allan Carswell Observatory. If it was clear, we could we could try to track its path. But we don't exactly know when and where the impact will occur. There's a lot of uncertainty about the orbit of this object, and this happens to a lot of pieces of space debris, not just Cosmos 482, but it's gets to be hard to track. It gets to be very unpredictable. So you can see where it's going, but only up to a very small window into the future. And so we kind of have to wait until it actually starts kind of going into the atmosphere fully before we're going to be able to get good tracks on it. It is half a ton of metal meant for Venus. So I would put some, if there was a betting pool going on, I would put something on some of it surviving the atmospheric reentry. It was, designed to survive Venus, so I think it has a very good chance of some of it coming down. But on Earth, your chances statistically are that you're going to end up in water just because Earth is mostly covered by water. So it will likely end up in the ocean, is what most people are thinking, but we won't exactly know until it does come down, and it might be the 10th, or it might be there's some error bars on that. So it is very much a watch this interesting space, and of course a good chance to read a little bit about the Venera program that the Russians ran back in the 70s, because we had, of course, the first spacecraft ever to transmit data from the surface of another planet, and it was Venus. It was Venera 7 in 1970, which actually made it to the surface despite a ripped parachute and despite the fact that it was Venus. And it survived for 23 minutes, sending data back. So these were absolutely amazing, amazing crafts. And of course, we have, if it does land somewhere where it's recoverable, I guess the other thing the other place these tend to come down on is in the desert of Australia. It's happened a few times. So Cosmos 482. It would be interesting to see if it is recoverable, and of course, seeing some of that technology back on Earth today would be a wonderful thing for all historians and science fans alike. Now, space law does require that space junk be returned to its national owner. However, if it does come back to Earth, in this particular case, Cosmos 482 was actually disowned. So the Soviet government, which launched it in the 70s, denied all knowledge or ownership of this satellite. So ownership of this satellite will theoretically, and I guess it will depend on your government, fall to the person whose property it falls on. So if it, worst case scenario, it lands on your house, best case scenario, it lands in your yard, and you then get to own a real piece of satellite history. So it is pretty interesting stuff, and of course, it is happening right now, which makes it a very interesting news item.
Yeah, there's a couple of interesting little points in on the law aspect. So, first of all, the Soviet Union doesn't exist anymore, so the country's gone. But also, the Soviet space program, you could always tell a mission failed if it had the name Cosmos. So this is a
Mm,
Venera spacecraft, but as soon as it failed, they rebranded it as Cosmos, and just a strictly test mission, and immediately, we're we basically disowned this failed mission. But so I think we've got just a few minutes left to do one last item. As reported in the universe today, on April 30th, the Hubble Space Telescope, which has got to be one of the best investments in space science ever, spotted a magnastar traveling through our galaxy. Now, magnastars, and my computer took this minute to freeze, there it is. Magnastars are actually very similar in structure to neutron stars, but they have intense magnetic fields. And a team of astronomers by the European Space Agency, led by researcher Ashley Crimes, used the Hubble Space Telescope to track a magnastar called with a very charming name, SRG 0501. SRG stands for soft gamma repeater, and it's whipping through the Milky Way at a rate of 65 kilometers per second, which is fast. The big challenge that they're trying to figure out is where it was born. Okay, so as a stellar object. So as I said, magnastars are very similar in structure to neutron stars, and these are produced when the core of a supernova in the core of a supernova. So supernova stars are generally 8 solar masses or more, but they're not big enough to make a black hole, which is probably in the order of 20 solar masses or more. When the star reaches end of life, the force of gravity, these stars are massive objects. The force of gravity is so strong, it actually pulls electrons from their shells into the atomic nucleus of its core material. And it ends up creating a sphere of solid neutrons with an incredible mass density and thus intense gravity. And magnastars also have these wild magnetic fields, and nobody's quite sure why. There are only about 30 of these in the Milky Way galaxy that we found, that we know of. And they aren't very big, they're about 20 kilometers across. But their tiny size belies the incredibly strong magnetic fields they generate. These stars can emit more energy in a single burst than the sun would emit in 100,000 years. And as the folks at NASA like to say, those fields are so strong that if one flew by Earth at the distance of the moon, all our credit cards would be wiped out. Actually, all our electronics would be wiped out likely. But what would be far worse is the gravitational effects of that flyby. You don't even want to think about it. So this Magnastar, SGR 0501, is about 6,500 light years away from us, which is comparatively close as such things are measured. It's actually close to a supernova remnant called HB9, and initially everyone thought the two might be associated. But looking at how they're both moving, it turns out not to be the case. And looking back along its path, we can't see a supernova remnant that created it. So there's a couple of other ways these could form. One would be two neutron stars merging, and the other would be a white dwarf in orbit around another star, accumulating so much material from that star that as it orbited, that it grew big enough to eventually become a neutron star. That might be the best candidate in this case. But Magnestar birth rate, this is a quote, Magnestar birth rates and formation scenarios are among the most pressing questions in high energy astrophysics, with implications for many of the universe's most powerful transient events, such as gamma ray burst, superluminous supernova, and and radio burst, and that's from Nanda Ree of the Institute of Space Studies in Barcelona. So I guess that's bringing us near the end of our show tonight. So I guess what I'll say is, we're at time, and you have been listening to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde, who's the director of our observatory, and myself, Paul Mackin. The podcast and past episodes are available wherever podcasts are distributed. You can also connect with us on Instagram at the handle at York U Observatory, or on Facebook at Allan I. Carswell Ob. Our website is yorku.ca/science/observatory. And we have lots of interesting content there. And if you're so inclined, it's a great place to make a donation to our student-operated, not-for-profit observatory. And that is a charitable deduction. That's a valid charitable deduction for your income tax returns. It's too late for this year, but you can always think about next year. Thanks for tuning in this evening. We wish you clear skies and good night, and may the 4th be with you.
Absolutely. Clear skies, everyone.